A can is most vulnerable at its double seam, the place where the can body joins the can lid. And if the double seam isn't doing its job, the can may leak and food may spoil. If food spoils or there is contamination of any kind, that's a major problem for everyone, sometimes a life-threatening one. If the public can't trust the products we make, they won't buy them, and then we're all out of work. Hi, I'm Ed Gold. This program is for people who are learning to evaluate the double seam. Seam inspectors, those of you who inspect cans as they come off the line, protect everyone. Your job is to make sure that closing machines are doing their job properly. Seam inspectors are really like detectives, tracking down unsavory characters like this deadhead. This double seam is not made properly. As you can see, it's rounded instead of flat. Now, evaluating a double seam isn't easy. It takes lots of practice. So we brought in someone who's been practicing for 17 years. This is Tom Kaler of Hanover Brands, a supervisor of seam inspection. Tom is certified at a national Better Process Control School. Thanks for coming in and helping us out, Tom.
I'm glad to be here.
Tom, what do you do first?
We do two types of seam inspection. Okay, we do a visual seam inspection every half hour. We are looking for false seams, sharp seams, cutovers, anything that could be seen with the naked eye before we tear the cans down. We also do a visual seam on the cans that we are about to tear down. That way, if we do find a critical problem, we can stop the line right there and eliminate some of the costs and so forth of running extra product.
Now, which end of the can are you looking at?
This would be our end of the can, the canner's end. This is the end that we have put on the can. This is our major priority, to make sure that our end was put on that can properly. And then we also do an inspection on the manufacturer's end of the can, just for visual defects.
What about the seam on the side of the can?
Well, the side seam, you can do a visual check of the side seam also. The only thing you can tell by looking at this seam is you have an open weld or an open seam. But you really won't be able to tell a whole lot at that side seam until the can is torn down.
Most plants have thousands of cans moving down the line all day long. How do you keep track of which cans came from which seaming head?
Well, let me give you a little demonstration. If they're not pulled off consecutively, we won't be able to tear our cans down and know which heads we were tearing down. Okay, here we have 6 cans. Say that the seamer that we were working on had 6 seaming stations on it. We pull 6 consecutive cans out. You must keep them in line. Now, on the number 1 head, we have a mark on the inside of the actual cover hook. Okay, now I'm going to look for the number 1 mark. I happen to find it right away. This here would be your number 1 mark. We have this mark on our chuck so we can identify which seaming head is number 1. All right, since we know this is number 1 and all of our cans are pulled off consecutively, this will be number 2, number 3, number 4, number 5, and then number 6. That's how we tell which cans came from which seaming heads.
Now that you've got your cans, what do you do first?
First, we're looking for any visual defects, like this false seam here. Here, the flange was bent down on the can and did not allow the cover hook to interlap with the body hook, and that gives you a false seam. Okay, now we have a double lid. And with a double lid, what actually happens, 2 lids sticking together, going onto your can, and of course, you can't put all that metal into one seam, so your metal comes out the bottom of your seam. Okay? The other things we have are sharp seams. Now, a sharp seam is a very common problem you'll see in evaluating your double seam. Sharp seams have a ridge normally around the top of your can, and you can feel that with your fingernail. It'll clip right on the edge of there, and that comes from your cover hook rolling up over your chuck. We also have a droop. Most droops are most commonly seen at the side seam where you have excess solder that may be in the seam. Other causes of a droop could be a dent in your cover curl or in your body hook that did not make a false seam but may leave a droop somewhere along the outside edge of your seam. On this particular seam, which is very hard to see, we have a jump seam right at the side seam. We have a flat seam here, hits your side seam of the can, and jumps over and becomes a jump seam. When you tear this can down, you'll have a very loose wrinkle right beside that side seam. And that's because when that roll hits that metal, it'll jump over. Here's a can that has a cocked body. You can greatly see the difference from this side of the can to this side of the can. And most of the time you'll see a cocked body at your side seam. What happens there is your body's flanges do not meet up. This can has been improperly put together before the manufacturer's end was even put on the can. On this can here, we have a deadhead. What happens here, the seam is rolled out flat and then hits your side seam, jumps over, and does not roll out the rest of the seam. This happens when the can turns with the roll instead of holding still in the chuck. This lid here is a damaged curl. If you have a damaged curl, you will not get a proper seam. What can happen here is that this lid will not overlap with the flange of the can. You'll get a false seam or a possible droop. Now this can here indicates a severe damaged flange. This will cause false seams or misplaced covers within your line because your seam lid cannot meet up with your can body. Last but not least, we have V'ing. V'ing is mostly caused by loose first operation seams. If a first operation is not tight enough, it means you have too much metal there to work with. That metal can only go so far, and then it comes out the bottom, and you'll have V'ing. Most times, if you just tighten the first operation, the V'ing will go away. That's not always the cause. It could be V'ing due to excess compound or a product in the seam, or anything that could cause you a false seam can also cause you a V.
Tom, tell me about that poster I see behind you.
Well, this poster should be posted on all your can seaming plants. It has all the critical defects, your minor defects, explains to the inspector exactly what they're looking for. They can use that as a reference anytime in making a judgment call.
Once you've looked for these defects on your visual inspection, what do you do next?
Well, now we're ready to take the measurements on the double seam. We're going to be looking for thickness, width, and countersink.
What tools do you use?
Well, we use a micrometer to check thickness and width of the double seam. You want to make sure before using your micrometer that you always make sure it's on 0. If it's not on 0, you'll be reading over or under your spec. On the back of your micrometer, there is a channel. Okay, when I turn the cylinder open, the channel will open up. That's where you'll be taking your measurement for your thickness, your width, your cover hook, and your body hook. Alrighty? So first we want to check the thickness of our double seam. So we put the micrometer on, tighten it but not too tight, just snugly so you don't damage the seam. We're going to start a 1/2 inch from the side seam to the right. Then you take your reading off your micrometer, which here is a 49. Then we move 1/3 around the can and check your seam thickness again. Here our reading is 51. All right, and approximately another 1/3 around that can, we're going to take another reading. And here we have 49. So our range for this seam would be a 47 to 51. And that's how you measure your thickness.
And how do you measure the width?
The width, you turn your can to the side, and we measure the same places, but only we're measuring the side of the container. Again, we start a 1/2 inch from your side seam. Take your measurement, turn your can approximately 1/3 way around, and take your measurement again, and then turn your can approximately 1/3 way around and take your measurement again.
What about countersink? It doesn't look like the micrometer could measure the countersink.
No, we have a special tool. It's called a countersink gauge for checking countersink. A countersink gauge measures the depth from the top of the seam to the bottom of the lid. The countersink gauge fits in along your double seam. We also are going to measure this at the same 3 spots we measured our thickness and our width. We're going to measure right to one side of the side seam and make sure that you do not put it on the double seam side seam or you'll get a higher reading. And by sliding that back and forth till you see the needle pivot from a high range to a low range, and you want to find that middle range. That will be your countersink reading.
Now that you have these measurements, what do you do next?
We have a double seam analysis sheet. And on this sheet, we can record 1 through 6 seaming heads 3 times daily. And we can record the time, the can code, the seam thickness, which we have just taken, the seam width that we have just taken, and the